In this video, I will give an example of how to find a solution to a system of linear equation using the inverse of a matrix. So if we have the following system of equations, x1 plus x2 plus x3 is equal to 0, 12x1 plus 2x2 minus 3x3 is equal to 5, 3x1 plus 4x2 plus x3 is equal to minus 4. So first we need to write our matrices. Our matrix X is x1, x2, x3, and matrix D is equal to 0, 5, minus 4. In order to determine whether it will be possible to find a solution, we need to find a determinant of A. This is equal to 1 times 2 times 1 minus 3 times 4 minus 1 times 12 times 1 minus 3 times 3 plus 1 times 12 times 4 minus 3 times 2. This is equal to 1 times 14 minus 1 times 21 plus 1 times 42 is equal to 35. So we have the determinant of A equal to 35. This is not equal to 0. So we know that A is non-singular and a unique solution exists. Next, we have to find A minus 1, which is equal to 1 over the determinant of A times the adjoint of matrix A. For this, we need our matrix C, which is our matrix of cofactors. Therefore, we need C11, which is equal to minus 1 times M11's determinant. C12 is equal to minus 1 to the power of 3 times the determinant of M12. C13 is equal to minus 1 to the power of 4 times the minor M13's determinant. This is equal to 14. This is equal to minus 21. And this is equal to 42. C21 is equal to minus 1 to the power of 3 times M21's determinant, which is equal to 3. C22 is equal to minus 1 to the power of 4 times M22's determinant, which is equal to minus 2. And C23 is equal to minus 1 to the power of 5 times M23's determinant, which is equal to minus 1. free 1 is equal to minus 1 to the power 4 times the determinant of minus m free 1, which is equal to 42. C free 2 is equal to minus 1 to the power of 5 times the minor free 2 1's determinant. This is equal to minus 5. This is equal to minus 15, and C free is minus 1 to the power 6 times the determinant m free, which is equal to minus 10. This is equal to plus 15. So our cofactor matrix is equal to 14 minus 21, 42, 3 minus 2 minus 1, minus 5, 15, minus 10. We know that the transpose of C is the adjoint of A. So it's 14 minus 21, 42, 3 minus 2 minus 1, minus 5, 15, minus 10. This means the inverse of matrix A is 1 over 35 times the adjoint of matrix A if we want to solve for x, we need to take the inverse of matrix A times D. The inverse of matrix A is 1 over 35 times 14, 3 minus 5, minus 21, minus 2, and 15, 42 minus 1 and minus 10, times D is 0, 5, and 4. So first, let's check our conformability condition. This A, the inverse of A is a 3 by 3 matrix, and matrix D is a 3 by 1 matrix. So yes, we can multiply them, and we will end up with a 3 by 1 matrix. We want X to be a 3 by 1 matrix, so our solution will hold. So our 1 over 35 remains where it is, and then we simply multiply these two with each other. So we take row 1 times column 1. So that will be 13 times 0 plus 3 times 5 plus negative 5 times 4. So we have our D variables should be minus 4. As you can see, I just copied this incorrectly, so that's minus 4. So what do? We take row 1 times column 1. 14 times 0 plus 3 times 5 times 5 times minus 4 is equal to 35. Then we take row 2 times column 1 minus 21 times 0 plus minus 2 times 5 plus 15 times minus 4 is minus 70. And finally, row 3 times column 1 is 42 times 0 plus minus 1 times 5 plus minus 10 times minus 4 is equal to 35. Now we have a scalar times a matrix or vector, and we simply multiply the scalar with each element in the matrix, so we are left with the matrix 1, minus 2, and 1. This means that x1 is equal to 1, x2 is equal to minus 2, and x3 is equal to 1. If we take these values and replace it back into equation 1, 1 minus 2 is minus 1 plus 1 is equal to 0. So we know we have the correct solution.